Welcome, and I'm Professor Engelhardt, and we are continuing our series here on the principles of macroeconomics, looking some at economic measurement, specifically how we measure economic activity. Right, so let's get into it. Quick overview of what we're planning to talk about. So first, we'll talk about how we measure gross domestic product, being kind of a major way that we measure economic activity. Then we'll look into how gross domestic product can be used and some tweaks that we make to it to make it useful for specific comparisons. Then finally, we'll look at some limitations of GDP as well as alternatives to it that try to capture elements that may be left out or tries to de-emphasize some elements that maybe shouldn't be in. So the big question that we're trying to answer with this topic is the question of how big is the economy? Tied to that would be questions like, is the economy growing or is it shrinking? Are we wealthier than before? Are we poorer than before on the whole? Right? So these types of questions are really important, especially if, say, a lot of the time when we're looking at economic policy, we want an economy that's growing. So how can we tell if things are working if we don't know the economy is growing or not? Is really the logic behind this. So the big question then is, how do we even determine, right, how big the economy is? And that is what we're looking for right now. Now, the typical answer, right, is we use gross domestic product. It's the main measure we use to figure out how big the economy is. Now, by definition, gross domestic product is the value of all final goods and services produced within a country in a given year. So I'd like to do, to understand this a little bit better, I'm going to take that definition and we'll break down the different phrases in it in order to get an understanding of how all of these play a role in the way we determine or calculate GDP. So, the value, we already have a problem because we need a common unit. After all, say if we have an economy that's producing, say, 3 cars and 20,000 apples, how do we add these together? They're both part of the economy, but how do we add them together without there being some kind of common unit? Right, so the solution is that we use dollar values. After all, cars have a price, right? So those 3 cars, if we multiply them by the price, let's say it's $40,000, that tells us we just produced $120,000 worth of product. Meanwhile, those 20,000 apples, let's say they're worth $2 a piece, so that now that's $40,000 worth of product. We can add together dollars and dollars, right? So that is really what we do here. So whenever you look at a measure of gross domestic product, it's going to be stated in terms of currency. Since I'm an American, I'm talking about the American currency, so US dollars in my case. Okay. Now, the next phrase, because the value of all final goods and services. So emphasis here is on the word final. Right? So why is it that we focus on final goods and services? Well, think about this case. Suppose we have a farmer. The farmer grows wheat, then takes that wheat, sells $1 worth of it to the miller. The miller in turn takes that wheat, grinds it up into flour, then sells that flour for $3 to the baker. The baker then takes that flour and bakes bread with it and sells the bread for $5. So how much did we just produce in terms of product? Well, let's see, we had $1 of wheat, $3 of flour, $5 of bread. So add it all up, and that would be $9. So the question is it really accurate to say we produced a $9 worth of product at the end of the day? Well, the idea behind GDP says no, that's not really true. Because after all, really what we ended up with, we didn't end up with bread and flour and wheat, we just ended up with bread. That's really the final good that we got. That is what we are getting that actually provides satisfaction, right, for people. Right. So then how do we reconcile, right, this $9 and the $5? Well, when we think about that $9, the problem is what we call double counting. That is that $5 of bread, that value included, right, the value of the flour, that $3. And the $3 of the flour, that included, right, the value of the wheat, which was $1. Right? So if we break this down, we can think in terms of what we call value added accounting. So the question is, in each stage of production, how much additional value do you get because of that? Right? So we start out with the farmer. Let's just say that they have a very simple production process. They're not really using lots of inputs, right? So they just have the wheat. is worth nothing. It's just bare earth, I suppose. And then it comes to wheat that we can sell. So it's $1 of value. The miller then takes that thing worth $1, converts into something worth $3, right? So he just added $2 of value. The baker takes something worth $3, adds another $2 to it to get something worth $5 in the end. Right? So when you add together the value added, it's $1 from the farmer, 2 from the miller, 2 from the baker. Added up, we've got $5 total. Right? So it's $5 of value created. So that is the solution we use. We use value added accounting using prices of goods to determine the weight of their value. The next phrase, produced within a country. So this is all based on the reality that if we're using this to inform economic policy, policy tends to be bounded by borders, which means, right, we need to include things that we produce here, but then nonetheless we may not sell here. So we call it an export. We also need to make sure we don't include things that may be purchased here, but nonetheless were not produced here. It's what we call an import. Right? So we need to make sure when we do the calculation, include the exports, which were produced within our country, do not include the imports, which are not produced within this country. And the last phrase, in a given year. Right? So this does raise a problem. Well, what about partially completed goods? So think about the farmer, the miller, and the baker. What happens if we get through the milling process and then December 31st hits? Bam. We don't get the bread baked. What do we do? Well, here, value added accounting is the solution again, right? So we know that we're going to end up with something worth $5 in the end. At December 31st, we already have the flour. The flour is worth 3, so those $3 get included right, during this year, whereas the next $2 of value, which are going to happen probably sometime in January, right, that would be included in the next year. So the value added can handle these partially completed goods, these goods in process. So then how do we actually calculate this thing? Well, there are 3 different approaches we use, and we actually combine them to come up with our estimates for what GDP is in a given country. Right, so the first is what we call the expenditure approach. The expenditure approach, sometimes thought of as the demand side approach, so we think about spending. Right? So what types of categories of spending do we have? Right? So there's consumption. So as people go out, we buy things, we buy new clothes, we buy peaches, whatever, right? All of these things, we can look at the spending there, and that provides us with a sense of what is the value of the stuff we produced. We have investment. Investment includes things like we build new housing. So that would be new production that happens that people are buying that is valuable, certainly. Investment also includes things like inventories. Right? So those goods in process tend to end up being held in inventory. So inventories would be part of investment. Government purchases. So the government goes out, it buys new aircraft, it buys new um, whatever it happens to buy, right? New buildings and the like. All of these would be included as things that we produce within the economy. So government purchases would be included. And then finally, net exports. Net exports are there because, again, there are things we produce that aren't included in the other categories. Those would be exports because we didn't sell them here. And then imports are there really as a canceling term to cancel out things in the other categories. And this is where there's sometimes a misunderstanding. Is it because we take those imports and we subtract them off, it makes it sound like if we import a lot, our GDP is going to fall. Right? But that's not really what happens. Right? So if I buy a doll from Bangladesh for my daughter, what happens to GDP? Well, through the expenditure approach, 2 things happen. First, imports have gone up. So there'd be a subtraction term. But that's not the only place this doll shows up. It also shows up in consumption because I am spending that money here within the United States. Right? So the consumption goes up, imports go up by exactly the same amount, so they cancel each other out. So that's really the purpose of that minus imports is that we have imports in these other categories getting added in. We need to make sure we take them back out so they're not included. Another approach would be the production approach, which is sometimes called the supply side approach. So here what we do is instead of thinking about the categories of spending, we think about the different categories of goods or services that are being provided. So things like non-durable goods, so goods that don't last for very long. Peaches would be one example of that. Uh, Durable goods would be those goods that can last a while. So things like cars, right, would fall under that category. Services, haircuts would also be included because we do want to capture that. Then structures, so residential housing would certainly be part of this. And then finally, that change in inventories, these things that we have produced this year but have not yet sold. And so it's another way of, again, trying to measure the same thing. And finally, the third approach is the income approach. This is based just on the reality that anytime somebody spends money, someone else is earning exactly that same money. When I go and I spend, say, $7 on a bag of apples from an orchard, to me, that shows up in the expenditure. To the farmer that has grown those apples, it's part of their income. Right? So exactly that same money, my spending is their income. So we can go through and look at everyone's income, add them up. It should also end up adding up to that GDP. Right? So here we add together the different types of income: wages, salaries, other forms of employee compensation, interest that people earn on loans that they give, or a savings account, for example. Rent would be another one. So the landlord is providing, right, housing services. So the rent that they receive would be part of that. And then finally, profits that are earned, either by corporations or by small proprietorships, smaller businesses, and the like. So these are three different approaches that can be taken to measuring the same thing, right? That is gross domestic product. So then, right, the process in terms of when you get, boots on the ground trying to measure this thing, right, we actually use all three of these approaches. We try to gather data on how are people spending their money? What is the stuff that's being produced and how much? How are people earning money? And then to come up with an estimate of gross domestic product, we try to triangulate these three. So using these three different categories, we try to come up with our best guess of what gross domestic product is in any particular period of time. So normally it's over the course of a quarter. Now, because it's an estimation process that requires gathering data, and gathering this data takes time, we actually end up releasing multiple estimates. So the first estimate, called the advance estimate, comes a month after the end of the quarter. So say if the quarter ended in March, this would come toward the end of April. And the advanced estimate is based on the least complete data. So there's a lot of trying to fill in gaps based on what you can tell from the data you have, what you would guess about the data you don't have, which is always the process we have to use. The second estimate then would include more complete data. It comes a month later. And then finally, the third estimate, which previously was called the final estimate, that comes still a month later. So we don't get that third estimate until a full quarter after the end of the previous quarter. And so it takes a good 3 months for us to get this final best estimate. But even that is still an estimate because it is not, in fact, practical for us to gather all the data on all the spending that occurs in the economy. Right? So it's just each step we get more and more complete data, but there is still some margin of error. Now you might wonder, why don't they publish a margin of error? Say our GDP was $30 trillion plus or minus 1.5 trillion or something like that. Well, the reason is anytime you see that margin of error, like you see this a lot of the time with surveys, uh, it's because there is a scientific way of calculating that. It turns out with this, there is not a scientific way of calculating this. Because it's just such a complex process, we don't know precise margin of error on each of the components that comes in, which means then we don't know a precise margin of error on the total either. So instead, I would say it's just a good idea to accept that it's not going to be perfectly correct. Now, one way that this gets reflected is when you look at the real expenditure-based equation, which is how normally when you see GDP reported, it's based on the expenditure basis. When you look at the actual equation in the release, it has these components. It has consumption, it has investment, it has government spending or government purchases, has net exports, and then it has this thing called residual or statistical discrepancy. Depending on the exact release, they'll use one of these two terms. Now, the reason for that being there, I really like the term statistical discrepancy because it tells us exactly why it's there. And that is, we did our best job that we could estimating GDP based on all the data we have related to income, expenditures, and production. We did the best we could estimating the amount of consumption spending we have based on the data we have related to that. We did the best we could estimating investment and government purchases and net exports. But we investigated each of these independently, which means then it's very possible our best estimate for each of these things doesn't add up perfectly. And that's what the residual or the statistical discrepancy is all about, that things didn't add up exactly the way we might expect. And that's really just because it's an estimation process. Now, generally speaking, this residual, the statistical discrepancy, is usually quite small. When you look over, say, the past several decades of history, we really never see it more than about 2% of GDP. That these numbers don't quite add up, and normally it's much, much lower than that, but 2% or so is right around the largest we see, either GDP being 2% higher than the sum of those four components or 2% lower than the sum of those four components. Let's get into some of the adjustments that we make to GDP. Right, so a problem we face is that GDP is calculated based on dollar value. We know that prices change over time. So certainly over the past 100 years or so, inflation has been something that we have had has more or less a regularity for a little bit more than that period of time. Right, so that means then, if we do a GDP calculation like this is just a very simple example. Right, so in 20XD1, right, there are $5 per apple, 20 apples sold, $10 per pair, 10 pairs sold, said GDP $200. Right? Then next year, 20XD2, apples are now $6 a piece. No, we produced 22 of them and got them sold. Pears have doubled in price. They're now $20 a piece. We produced and sold 11 pears. So added up, we end up then with a GDP of $352. Now, you do the math, that's a gain of $152, which would be 76%, right, of that original $200 GDP. So is it really fair to say, looking at this example, that the economy grew by 76%? I think most people would say, no, definitely not. Right? So that's the issue, that here, part of that change came just from a change in prices, a relatively smaller change in apple prices and an enormous change in pear prices. So is there a way for us to fix that? And this is what nominal versus real GDP is all about. Right? So the solution here is, why don't we hold prices constant? Now, the actual calculation is a little bit complex. I'll tell you more about it here in the next slide. But the basic idea is, let's use the same price for both years. Right? So let's say we're going to use the 20XD1 price for all of the years. So it's apples. We know they're not always $5. We'll act as if they're always $5. Pears are not always $10. We'll act as if they are always $10. Right? So then we do the math. We find out in 20XD1, $200 of GDP. 20XD2, if we use the same prices as the previous year, $220 of GDP. So it's a 10% increase. Now, this is obviously correct. After all, we went from 20 apples to 22, that's a 10% increase in apples, 10 pears to 11, that's a 10% increase in pears. The economy clearly grew by 10%. So in this case, it's fairly obvious what the right answer should be. And we got that right answer using this method. Now, of course, in reality, when we have a slew of goods, each of them, some prices going up, some prices going down, some prices do fall, especially say when you look at technology, something like that, those prices tend to fall, at least over the first few periods after new technology is introduced. And so when you have prices moving various directions, it's not going to be quite so clear, right? But in this case, yeah, it was very, very clear this was the right answer, and it matched exactly the amount of growth we saw in each of our two sectors, apples and pears. Now, the complication that comes in is it's not obvious why we should use 20XD1's prices. Right? Why shouldn't we just use 20XD2's prices? Right? So why should we use the older price instead of the newer? And there really isn't a good reason, to be perfectly honest. Right? And which year's prices we use can sometimes lead to a radical difference. Now, it wouldn't in this specific case because pears and apples each grew by 10% in terms of uh, physical growth of the apple trees, I guess. Right? It's normally not going to be that even. So because price really is the weight you're attaching to that good, which year you choose might really matter. So what do we do? The solution that we use now is a chained index. Right? So the idea of chained indices is that I'm not going to go too much into the detail, but it's a sort of averaging of the prices from one year to the next. Right? So the reason we call it chained is because it starts in a particular reference year, let's say 2017, right? So we start with 2017 dollars, and then we use 2017 and 2018 dollars to look at what's happening in 2018. Then we use 2018, 2019 dollars to use what's to look at what's happening in 2019, and you start building, in effect, just these links, right? The link from one year to the next, to the next, to the next, and so on. Or you can think of the links backwards. So For 2025, we go back to 2024, use the combination of those prices, 2024 to 2023, and so on back. So it's this chaining process to get us back to an original reference year. So whenever you look at real GDP data, that means it's inflation adjusted, it will always have a reference year attached to it, which means that we're trying to reflect the value of the dollar at that point in time, or the overall level of prices at that point in time. So a couple notes on nominal and real GDP. So one thing we can do with nominal GDP and real GDP is we can use it to find what we call a GDP deflator. So the calculation for that, take the GDP deflator is going to take your nominal GDP, divide it by the real GDP, that's the GDP where you're holding prices constant, and then multiply that thing by 100. So you're going to get a number, say if nominal GDP and real GDP are exactly the same, because it's the year you're using for prices, you'd end up with a GDP deflator of 100. If you really try, you can actually say this phrase. All right, so if we use the previous example, $252 was the dollar value if we let prices change. That's our nominal GDP. $220 is if we held our prices constant. So to take the ratio of the two, we ended up with a GDP deflator of 160. Now, we can actually interpret this to mean that between the year we took our prices from and now, prices went up on average about 60%. Start with 100 and the original base year is what we call it, added 60% to that. You can also use that same formula to convert nominal to real if you know what the GDP deflator is. So here, if I know the nominal GDP is 352, I know the GDP deflator is 160. Take the 160 divided by 100, take 352, divide by that, you end up with $220. So you can do this conversion various ways. Now, another note on nominal versus real, right? And that is that we can relate these things in percentage terms. That is, if we think in terms of percentage changes, the percentage change in a nominal value, and say in our case, that's GDP, is going to be equal to the percentage change in the real value plus the percentage change in the price. Right? And this can be used in all kinds of applications. So say I get a 5% raise in money terms, right? But at the same time, prices have gone up by 3%. So in that case, my real raise would be plug things into the formula. My nominal raise is 5%. I'm trying to find my real raise. My change in prices was 3%. So I need to do a little bit of algebra, subtract 3% from both sides. My real raise was 2%. So real, the change in real plus change in prices gives you the change in nominal. And then one last note, just in terms of terminology. So nominal GDP, sometimes the way that it gets called when you're looking at specific data, sometimes it gets called current dollar GDP, which really just means that we're measuring GDP using the value of the dollar for the particular year that's being reported. So 2025 is being reported in $2025, 2024 is being reported in $2024 of prices, and so on. Right? So if you look at a graph of current dollar GDP, it's going to look like it's going up much more rapidly than constant dollar GDP. And so because part of the reason it's going up is that prices are rising. Meanwhile, real GDP is sometimes called constant dollar GDP, just saying we're trying to put the value of the dollar, put it the other way, prices, all in one specific base year, so 2017 or something like that. Right, so it tells you what's the year we're trying to put all the prices in. Okay. So now we have GDP. How do we use the thing? Well, real GDP we often use to help identify business cycles. Right? So we can think of our GDP following over time, over the long period of time, it follows something like a trend, which is generally upward in most economies over the past century. But we don't stay on that trend all the time. Right? We have some instability around it. So there are times we have booms or expansions. Then we have peaks, or we could call it crisis. Then the economy falls, or we call it a bust or a recession. In extreme cases, we might call that a depression, although I seriously doubt we will ever use the term depression ever again, just because it's so associated with the really awful time of the 1930s. I don't think anybody wants to call it a depression ever, even though that was the common term before the 1930s. We had to come with a new name after that, apparently. Right, so we have things falling over the course of a bust or recession. Right? We hit the bottom, at the trough, and then we recover right back toward trend. So we can think of the economy moving through these phases of what we call the business cycle: boom to crisis to bust, trough to recovery. So, how do we determine the dating? So, this is something that the NBER, that's the National Bureau of Economic Research, and despite the name, it's not actually a government organization. They have a group of people, like it's literally a committee that decides, right, when it is that the business cycle has turned, either having a peak, therefore turning into a recession, or having a trough, therefore turning back into a recovery. Now, they don't bother trying to distinguish between whether is this increase a recovery or is it an expansion, a boom. They don't bother with that, but they do try to identify peaks and troughs. So when do things turn from getting better to getting worse, and from getting worse to getting better? Right, so literally a group of people associated with this organization of the National Bureau of Economic Research. Now, when they make these decisions about turning points, they use a combination of data. They don't just look at real gross domestic product. It plays heavily into the decisions, but they do look at a multitude of data, not just real GDP by itself. Now, usually they do make announcements about turning point peaks or troughs with fairly long delays. Usually it takes a few months for us to find out that a peak happened, right? So it might be, say, maybe the peak happens in February and they announce it in August because they want to have enough data to know that things are actually getting worse. They're even slower with identifying a trough. It often takes more than a year to identify that, oh, actually, the economy did in fact bottom out. So, for example, April 2020 was a trough. Right? That was not announced until over a year later in July of 2021. Right? So it takes a long time because they really want to be sure that the economy has turned around before they make this announcement. And that means having to wait a bit to actually get the data. Now, there is another definition for a recession, and that is that a recession is 2 quarters of negative real GDP growth. Now, this is used as kind of a rule of thumb of sorts. And in fact, this seems to align very well with what the NBER actually does in terms of their decisions, which means then this is something that we might be able to gather much faster because we know we get that initial uh, that advance estimate a month after the quarter's over. Right? So we can start making judgments about things there if we just use this very simple definition. Now, is this the official definition? It depends what you mean by official. I think most economists look to the NBER, but at the same time, we're perfectly happy to use this definition in things like textbooks and the like. And we're so happy to use it that, in fact, often Congress will use this definition in sort of recession escape clauses, which is not an uncommon thing. Say, if you have an act that is intended to, say, bring government budgets back toward balance, they don't want to force that in the course of a recession for reasons we'll look at later in the course. So they need some of identifying, are we in a recession or not? And often this is what they will point to decide whether or not we're in a recession. They're not going to say, let's look at what the NBER says a year and a half later. They're looking at, well, what does the most recent 2 quarters of real GDP look like? Right? If we're falling 2 quarters in a row, yeah, then we're in a recession, at least good enough as far as the law is concerned. All right, so comparing across time, we want to make sure we take prices into account. So we look at real GDP. What about comparing across countries? Well, here there are actually two adjustments that need to be made. Right, so the first is the currency adjustment. It turns out $1 is not equal to 1 yen or equal to 1 euro or equal to even one American dollar versus one Canadian dollar. They're not the same, right? So that means we need to adjust based on the currency. I'm not going to go into too much detail here. We'll look at international stuff later on in these videos, but I just want to point out that there are two different ways that they could try to calculate those changes, this difference in currency. One is what they call the market rate. This is based on, like, if I were to travel to Canada and change my American dollars for Canadian dollars, what is the exchange rate? How many Canadian dollars would I get for that American dollar or vice versa? Right, that's what the market rate is. Now, this one changes day to day, so it's not very stable. So often when we're looking at things like GDP, we don't use market rates just because it means we'd have to recalculate it every day. Uh, Sometimes faster than that, just to be able to do the comparison. Instead, we focus on what they call a purchasing power parity. This looks at how much real stuff, right, can you buy with two different sets of currency. So a second issue that shows up is population. So think about these two real GDPs. These are from 2024, adjusted to be in American dollars. These are not American countries. One of these countries has $188 billion in real GDP. The other has $93 billion in real GDP. Now, can we safely say that the first country is about twice as rich as the first? Well, turns out the answer is no. Because these two countries have wildly different populations. Right? That $188 billion was true of Nigeria in 2024. Their population is roughly 230 million people. Meanwhile, the 93 billion was for the country of Luxembourg, which has a population of under 700,000 people. Right? So Nigeria, they do produce twice as much, right, within their country, but it's spread over more than 300 times, right, as many people. Right? So are the Nigerians wealthier than the Luxembourgians? Probably not, right? So we need to take that adjustment for population into account. And that is what per capita GDP or GDP per capita is for. Right? It's to make this adjustment. Per capita is really just the Latin for per head, right? So GDP per capita, GDP per head is just GDP divided by population. You can do this with nominal GDP if you wish. You can do it with the real GDP as well, as long as you're clear. So real GDP per capita, nominal GDP per capita, and you're perfectly fine. It's the same type of calculation. This is also something that can be useful for a time series. So if we're looking at, say, the US across time, if we just look at real GDP alone, that takes care of prices, but it doesn't take care of the fact that we have a lot more people in the US now than we had in 1800. Right, so if just looking at total real GDP is probably going to be misleading in terms of how much better off we are now compared to then. So now let's get into some of GDP's limitations. It is a very common measure. It's not a perfect measure. Why? Well, one issue is that it's limited to market activity. So things like doing your own laundry, that adds nothing to GDP. Another issue is that it leaves out non-production things that do matter, right? So things like health, life expectancy, crime. These are things that certainly have an impact on people's well-being, on our standard of living, but nonetheless don't show up in GDP. Talk more about these in a minute. And then finally, there are some things that are included in GDP that maybe shouldn't be, right? So things like government purchases, right? So we have these different factors that then lead people to suggest that maybe there are other measures out there that we should think about. So here's some alternative measures that are nonetheless somewhat similar to GDP before we start dealing with more of these limitations, right? So one you may have heard of is GNP. This one, uh, me as the old person, like I remember back in the day when GNP was what you heard more often, right? That has changed. GDP is the thing we talk about now. GNP, it was calculated, it's very similar to GDP conceptually, except it's calculated on the basis of citizenship rather than on geography. Right? So it isn't quite as preferred now, mostly because we realize that policy is largely geography based, right? So it doesn't really matter whether the person is an American citizen or not, if they're within our borders producing stuff, right, then they're going to be having an impact on the American economy. The idea. Similarly, an American living abroad, right, probably doesn't have nearly as much impact as a foreigner living here. Okay. Also, another alternative would be gross national income, right? So this is very much based on the income basis. So the way you calculate this, you start with GDP, but then you add to it any income we get from abroad. Right? So things like Americans invest in foreign companies, and we might receive dividends from that. So this is money that we are bringing in, not including GDP, because we didn't produce anything here for it. But nonetheless, it is part of our national income, and that Americans are receiving this income. And then also any income that is sent abroad is taken out of this. So there may be people in the US that produce, they earn an income here, so it would be included in GDP, but the money doesn't stay here if you send, say, a chunk to a foreign country or something like that, right? So say if I make donations or something like that to international charities that are largely based abroad, in that case, that would get subtracted out of gross national income. And then finally, what we call net measures. So you can have net domestic product or net national product. What these do, they subtract out depreciation simply because part of the stuff we're producing is just replacing other stuff we already had. So this is trying to get at, are we actually adding to what we have rather than just replacing what we have? All right, so now let's look a little bit more at this idea of limiting things to market activity. Right. So the problem here is that production for yourself doesn't have a clear market value. Because of the lack of market value, it doesn't get included. Now, this creates a problem in that if we move from having more self-sufficient households, say where you have a large garden, so you grow food yourself, you save seed from year to year, so then you can just replant your garden and all of that. You compost, so you don't have to go out and buy fertilizer, all of that. Everything that you're producing in your backyard garden doesn't count in GDP, despite the fact that it obviously does lead to you having greater well-being. So if we move away from that type of structure, people having gardens, to instead market-driven activity, so you're always buying food from the grocery store, now GDP has increased substantially, even though maybe your own well-being hasn't increased substantially. You're eating the same kind of stuff, just instead of growing in the backyard, you're getting it from somebody else. And so maybe you saved yourself some in terms of leisure time, but that's basically it. And so that is something that can be an issue that because of the possibility of moving back and forth between self-sufficiency and market activity, we end up mismeasuring how well off people are if we just focus on GDP. There are also some things that are inappropriately included. Right? So Simon Kuznets played a huge role in the 1930s in the United States in developing our calculations for gross national product, which was what was commonly used at that point in time. And so what he suggested was that the G, that is government purchases, should not be included. Because in his mind, this was very much like production at home. There really isn't a market value. After all, I do not pay the police, right, to give me a ticket. That is not the way the ticket works. I'm not paying them for the service of having stopped me from speeding. That's not the way it works. Right, so the things that government is producing and purchasing, it really doesn't have an obvious market value. Right? So according to Kuznets says because it doesn't have a market value, we really shouldn't include it. We should only focus on those things that have a clear market value. Now, the big thing that changed that and clarified it when the Department of Commerce was putting together finally how they're going to calculate this was World War II. In World War II, we were clearly producing a lot of stuff specifically for the military. And if that wasn't included, it would look like we weren't producing very much, right? So in order to capture the fact that we were producing so much that was military oriented, G is included. Now, Murray Rothbard is a more modern economist in the last half of the 1900s. He took Kuznets' idea and said, you know what, there's a fair point here, and that it's not obvious when the government provides a good or a service that people actually want it and that we'd be willing to pay for it if we actually had to pay for that good or service like it's a market good. Right? So he suggested two alternative measures. One is what we call the gross private product, where you take GNP, again, it's on the GNP basis, and subtract off any income that comes from the government. Because this is very much following Kuznets' idea that we don't really know the value of the things the government's providing, so we shouldn't include it. Then Rothbard goes a step further and says, no, actually, when the government does stuff, it is actually taking resources away from the private economy. Right? So it's not just that we need to not include it, we also need to actively subtract it out. Right? So he says there's this other measure we're going to call private product remaining. That is what is left of what is privately produced after the government has taken whatever it's going to use. So this is that gross private product, then subtract off the higher of either government expenditures, because every dollar the government spends gives it command of resources, or taxes, because every dollar the government takes in taxes is a dollar that we can't spend in the private economy. Right? So that is, the measure that he uses here. So this is really just pointing out that the government consumes, right, some of the products produced by private industry. Now there are other things that get left out. I mentioned before non-market activity. There are also other things that affect our standard of living, our well-being, that do not get reflected in gross domestic product. So a couple alternatives. One is the Human Development Index. So the idea of the Human Development Index is we start with gross national income, that being what we use to satisfy our material well-being, but we add to that also education, our education level, and then also life expectancy being something that reflects health. Right? So this was developed by the UN Development Program to really try to get a more complete picture of how well off societies are. It's probably unsurprising, but you do generally find that those economies that are wealthier in terms of national income or GDP tend to also do pretty well in terms of education and life expectancy on average, though there are some exceptions. But for the most part, that's what we tend to see. But nonetheless, this is trying to take a more complete view of human well being. Another measure called the Genuine Progress Indicator similarly says, well, GDP tells us something, right, but it doesn't tell us everything. Right? So what they suggest is we should take GDP, we should add in that non-market production, so home production, volunteer work that you may do that produces some kind of value most likely, but at the same time is not something you are paid for, and therefore it's not included. Right? So add that in. But then we can subtract off things like crime, pollution, resource depletion, and any resources we spend, right, in order to try to solve these problems, right? So that's kind of the idea here is that crime, pollution, resource depletion make us worse off, right? So we want to subtract those. Now, I will note there are other factors here. They also include things like commuting time and the like, but this basic formula captures the idea of what they're trying to do. So take GDP, add in other things that add value, subtract out things that make us worse off. Now, this genuine progress indicator, or GPI, is usually used by green economists, people that are studying environmental sustainability, because they're really particularly concerned about things like resource depletion and pollution, and how much of our resources have to go to just making sure people don't steal what we already have. There's another measure called gross output. Gross output, what it does, it actually includes those intermediate goods. So instead of focusing just on final goods and services, it says all goods and services, which means it will do some double counting. Now, the reason for this is that it's really to emphasize the importance of intermediate goods, right, in the economy. Turns out a lot of what we do is produce goods that are supposed to be further worked on in the economy. So this is something that was emphasized by the economist Mark Skousen, just because he thinks that GDP, the way that it is normally calculated, overemphasizes consumption and the production of consumption goods, and underemphasizes the production of other goods, right? Things like machinery, for example, which is very important, but nonetheless tends to get subtracted out. So just to sum things up, right, so GDP is the common measure for how we value the national economy, how much value the economy is producing in any specific period of time. And with these adjustments that we make, things like real GDP or per capita GDP, it can provide useful comparisons, right, across time and also across countries. However, it's not going to be a totally perfect measure of human well-being. Remember, its purpose is to figure out how much stuff we're producing in markets. Its purpose is not to figure out how well off we are necessarily in every aspect of our lives.